All right, we're going to jump into lesson 3.1 here for Math 3C. This is going to be on cross sections of 3D figures. And we'll start with a definition here. And the definition says this is a definition for a net of a 3D figure. And it's a diagram of the surfaces of the 3D-dimensional figure that can be folded to form the three-dimensional figure. So basically, you can kind of think of this as if you took a cereal box, right, which is a three-dimensional figure, a rectangular prism, and you unfolded it. So all the flaps were flat and two-dimensional. That would be the net of that figure. And so that's what we're doing here. We're imagining that we are unfolding these pieces. So we'll start with a cylinder. And if I'm going to go ahead and unfold this, right, so this is kind of different. Imagine it's a paper towel roll, and if you were to cut it open and unfold it, it'd turn into a rectangle. And then that rectangle, of course, would have a top and a bottom, which would be circles. And so we'd end up with a net that looks something like this, and we can go ahead and label those dimensions that they've given me, where we've got 12 feet here. And the diameter of each of these circles is 7 feet. Moving down to our rectangular prism, right? First, we should notice that we've got 6 different sides here for this rectangular prism. So as I unfold this box here, I should end up with 6 different two-dimensional rectangles here. So I'm going to start by unfolding the base here, which is this piece. Okay, so I'm going to start right there with that 4x2 rectangle. So we'll start there. Okay, and then if I were to take each one of the sides and flap those downwards, right, I'd end up with something that looks like this. Okay, so we flap each one of those down, and then the only piece that we're missing here is the top of this box, right? And so then that could end up on any one of these, right? So think about it as I'm unfolding this. That could end up anywhere here. So it could end up on the side here, right? Or it could end up on the bottom or on the left, right? Or up here. Okay, it could end up anywhere there. I'm gonna go ahead and attach that to the bottom here. Notice it's a little bit bigger, right? Same as the base there. It should be the same size as the base. And I can label these dimensions now. So we've got 4x2 and 4x2. That was the top and the bottom. And then these flaps here are each 1.5. All right. Okay, keep it moving here. It says, given the net of the 3D figure, name the 3D figure. So this time they're giving me the net, and for this one we can see it's got these triangular sides, and they're going to come together at a point. If you can kind of envision them coming together at a point, we know that means it's going to be a pyramid. And remember, a pyramid is always named by whatever the base is, and in this case we've got this rectangle as the base, so this is going to be a rectangular pyramid. All right. And then sliding over to letter B, it's the same idea here. Actually, these are the triangular sides here. They're going to come together at a point, so it's going to be another pyramid. But in this case, it's going to be named by whatever the shape of this base is, and this is a triangle as the base. So this is going to be a triangular pyramid. All right, so that's nets there. Next, let's look at a cross section. This is a region of a plane that intersects a solid figure. And so you can see they give you an example here. And so the cross section is going to be whatever the shape is that's made, as if we were slicing like a piece of paper through our three-dimensional object there. In that case, it would be a circle. The cross section would be a circle. So if we go to letter A here, right, we can see this time they are slicing this piece of paper through this cone, and we can see that the shape that is being created here is going to be a triangle. Moving to letter B, same idea, right? Another time they're slicing this piece of paper through, okay, this time parallel to the base, but it's going to give me a rectangle. Moving down to letter C, we've got this triangular pyramid, and we've got this cross section that is parallel to the base there, and that's going to be triangle. Okay, and then we keep going. And we've got the cylinder, and we've got the cross section going through it here. It's just perpendicular to the bases, which actually creates a rectangle. All right, so keep it going here. This time they're describing the cross section. So this one says a cylinder with a cross section perpendicular to the base. So first let me sketch out the cylinder. I'm going to do this the best that I can. I'm not a great artist here, but we've got a cylinder, right? It looks something like this. Okay, so there's our cylinder, and then it says the cross section is perpendicular to the base. So in this case, that means that it's going to be going up and down, right? Perpendicular, creating this 90-degree angle with the base. And so we can kind of picture it like this here. Right, so something like that would actually be a little bit like this. Okay, and we can see that that's going to create this rectangle as the cross section. Okay, and then letter F says a cylinder with a cross section that's parallel to the base now. Okay, so we've got another cylinder. Okay, so we got another cylinder, so there's our cylinder, and now the cross-section is parallel to the base, right? So notice the base is kind of going side to side here, so this is the base down here. So parallel means that our cross-section is also going to be going side to side, so they're parallel to each other here. And so when we do that, then we end up with a cross-section that's going to be in the shape of a circle because it's slicing straight through here, and we've actually seen that on the other side, right? Let me zoom in for you so you can see a nice photo of it. This is the cross section that is parallel to the base there, right, side to side, and we can see that it creates a circle. All right. Moving to the next part where you got rotations here. So it says describe the 3D figure generated by rotating the 2D figure around this line L. So imagine that we're taking this rectangle for this first one, right? We've got this rectangle here, and we're going to kind of spin it around this. Imagine that this was like a pole here, right? So if we're kind of spinning it around that stick there, then we're going to end up with some sort of a shape, and it's kind of tough to imagine for some students. So I kind of like to look at the vertices here and think about, okay, what happens if I were to swing this thing around? And what's going to happen is it's going to kind of generate a circle there and a circle there, and obviously the side of that rectangle there is going to create something that looks like a cylinder. And the same thing's going to happen here when we take this triangle and we rotate it around. Okay, we're going to end up with something that looks like a cone. All right, keep moving here. If we go to letter C, right, take this, say I have some point right there, and I start to swing it around, okay, to the other side. You can see what's going to happen here. It's going to create kind of a sphere. And then we get to letter D. We got a number of things happening here, so I'm going to just focus on these points to start, C and D. If I were to rotate these around, so swing these around, okay, we're going to end up with circle there, and swing this one around, end up with a circle there. I'm going to go ahead and connect these sides here, and so we've got like a couple different shapes happening here. So basically we have a cylinder with cones on the top and the bottom, right? So we've got a cylinder, and then we've got cones on the top and cones on the bottom. All right, so go to number 6. It says sketch and describe the figure that is generated by each rotation in three-dimensional space. It says rotate a semicircle around a line through the endpoints of the semicircle. So first, let's draw the semicircle. Okay, we'll say it looks like that. There's my semicircle. And now we're going to rotate it around this line that goes through the endpoints, right? Say my endpoints are here and here. And so we've already seen this. If I were to rotate this thing around, right, swing it around, it's going to end up giving me a sphere here. Next, it says rotate an isosceles triangle around the triangle's line of symmetry. So let's start with an isosceles triangle. Okay, something like that. And now it's going to rotate around its line of symmetry, which is the line that cuts it in half, right down the middle. And if I were to do that, okay, then we've seen this one before as well. We're kind of swinging this thing around. It's going to create a cone here. And then last, this one's tricky. It says rotate a line segment around a line that is perpendicular to the segment that passes through an endpoint to the segment. So there's a lot there. Let's go through piece by piece. First, it says rotate a line segment. So let's start with the line segment here. Here's my line segment. And it says around a line that is perpendicular to the line segment, and it passes through the endpoint of that segment. So we need to draw a line that's perpendicular to it, and it's got to pass through the endpoint. So if the endpoint is here, and we need to draw a line that's perpendicular to it, it's going to look something like that. So now we're going to take this green one, and we're going to rotate it around. Okay, and so it's going to kind of create this circle as we swing it around this perpendicular line here. So this is going to be a two-dimensional figure, which is going to be a circle. All right, that's it for today, right? I know sometimes this is tricky because it's a lot of visualization, and some students it's easy to see and some it's more difficult. So just keep working at it, ask questions if you've got questions. We could talk about it in class. All right, thanks for watching.